work in client server, so you can launch it from any laptop, for example. So from a Visa instance also, that allow you to control the instrument entirely. The parameters, the motors, anything you can control remotely. You can do almost everything except putting the sample in the instrument. You can do almost everything. And it's a complete solution with a lot of things around that. For example, you can log every manipulation. You can add some logging for people that knows logs. It's proposing the same kind of workflow. And soon we'll also have the control of the cameras to check how the environment is working visually. So actually working with Nomad is almost like being near the instrument. So we already prepared the fact that people will not be forced to work near the instrument. With that, we add Visa over it. So Visa brings the data anywhere, and actually it's not exactly that. It brings the user near the data. So from anywhere you can use a browser and connect to access all the data and also to access the previous software Nomad. So with Visa you can control the entire experiment. So once we put Visa in motion, we were able to provide the same, almost the same experience to users on the experiment without leaving their living room, for example. The main idea behind Visa is also that it allows collaboration and provides already software already installed on it. So you don't lose the 1 week or 2 weeks to configure everything. Is already in place, and the data is already connected to it, so you don't have to set up anything. And users comes and are on an environment already prepared for them in a matter of some clicks. It was obviously, and I think all the scientists and even the management understand that very fast during the COVID. It allows us to continue the experiment, and we decide rapidly that the main issue was how we provide the software version. So I will speak about that later, because of course when you distribute an instance with static software, it can be an issue when you want to have the last version or a different configuration, different compilation, and so on. It's quite complex. Globally, what you have to remember from that is, once we had this issue with the capacity to travel and so on, Visa helps a lot, and it helped in the same time the science and the IT, because the charge on the maintenance was very low once we put Visa on some instruments. So last updates, what we have done recently, we have worked around Visa, not on Visa itself, not on the software as I told before, except for WebEx, but around Visa, everything that works around Visa. So the first thing was the way we deliver softwares. We are now working with Obtainer, Singularity, which allows us to put softwares in a container, like a Docker, if you want. So we know stops shipping compiled or sources of software, but containers with a specific version, which is quite easier to understand for users. The second thing is that we distribute these containers differently also. We put them on a registry. So basically, people just grab what they want directly, like a repository or on any distribution. So again, it's really easier for people to use them and easier for us to maintain. We have done some statistics on usage, so thanks to Jean-François who asked that actually. But we have figured out recently how the progression has been made on Visa, and we plan to put that in a future version, potentially on Visa. Since we have changed all the distribution way of the software, we have from now we have any dependence on the platform we are running them. So we are able to change the version of the OS as soon as we want. So from now we are on a 2004 from Ubuntu. We have done a lot of improvement on user experience thanks to that. And we have also decreased drastically the size of the images. Before we were shipping all the softwares in the image, so it was around, oh, sorry, okay, I stopped that. We were on, yeah, I don't know. No. I can't. It's okay, it's okay, it's okay. It's okay. I will finish with that. So we decrease the size. That's it. And one last slide. Okay. Okay, great. And that's the last one. So to see an overview, what PaNOSC changed at ILL. Globally, it was an accelerator for the visa project globally, because a lot of other things was already in place. Remote work is no standard at ILL. We saw people working at ILL with visa because it's easier to access data and softwares. The IT maintenance is really reduced, so it's a gain of cost, of course. The data management is also on good track. We are working on DMPs and so on. So it's work in progress, but we are doing it. And we already know that it will be mandatory for a lot of things later. We have reduced drastically also the wasted time of configuring everything for experiments. Some scientists came to us to say that, so it's quite nice. And of course, the data is no more visible outside of ILL because we can work from everywhere, and the data portal is also included in the federated search, so it's easier for people to find data. Thank you.
Thank you very much, Erwan. And now I propose that we go with the next speaker, and we'll have some time for questions at the end. And Alessandro Olivo of CERIC.
Okay. So, for those who don't know us, we are an ERIC, in particular the Central Consortium. ERIC provides access to laboratory located in 8 European countries, and the research involves all the fields of materials like biomaterials, nanotechnology, and with a focus on life science and energy material. So CERIC represents a single entry point to more or less 60 instruments across all the partners, and it provides support to the user in order to, for example, prepare the proposal and for the dissemination of the result of the research. Okay, so this is an outline. Okay, here are listed all the achievements that we consider be accomplished at some level. So we have the data policy, the DMP, the metadata catalog, the DOI's minting, the file services, and EOSC interfaces. Okay, so let's start with the data policy. The data policy, we consider we consider the data policy as the cornerstone of our scientific data management services that allowing us to develop standardized services based on the know-how and the expertise of the facility that already operating. Okay, so we have the data policy adopted, and now is governing the CERIC-ERIC calls. For the data management plan, okay, At the same time, since we have 80 partners, the data management plan is becoming one of the most challenging and powerful initiative, and we think that this data management plan can be help us to train the partners and the users to see the benefits of the FAIR data. So I saw yesterday there was a slide of work in progress status of for CERIC of the DMP, but since last week we started to create DMP in an integrated way with VUO using data stewardship wizard. So we have already 40 DMP created. Okay. So CERIC now is using VUO as user office platform. Is a web platform. It's a web platform developed by Electra. It is one of our partner facility. It not integrates some cataloging functionality, so we have to pass to some real catalog. Nevertheless, in VUO, there are a lot of metadata, generic metadata associated to the proposal, like principal investigator, abstract, and so on. So we have to adopt some catalog. We chose ICAT. That is supported by large community of pan-European community, and is ready for EOSC. It has its own OI and search API implementation. And okay, so now we have the last version of ICAT in place, and has been populated by this metadata ingestion system that fetch the metadata, the generic metadata from the VUO, fetch the experimental metadata from files, and ingest them in the catalog. Okay, another achievement is the DOIs minting. So we consider DOIs as a building block of a FAIR ecosystem. We are minting DOI for investigation, but we have already planned to extend this functionality to the dataset. And we are using DataSite, that is a DOI provider well known in the PAN community. And this is our link of the repository. Okay, during the project we developed and deployed several services and software. Here are mentioned 3 of them. We have the data uploader. Is based on rclone, and we use the data uploader in order to upload data to the CERIC storage that is hosted by Electra, and in an integrated way with VUO. Okay, this is useful for those instruments which are not integrated in the control system, which is the case for some instrument in Electra and several instruments in the other external partners. Okay, and then we can go. Okay, we have H5 Nuvola. We developed H5 Nuvola, which is a web tool, comprehensive web tools, which can access to the storage system, and the user can browse the data file, their data files, can process their data files, and have a glance overview of the content of H5 files and the common image formats and PDF and some text. Okay, and we deployed Visa too. Okay, last slide. These are all the ways in which CERIC expose metadata stored in the catalog. So we have OIPMH, mainly at PaNOSC search API. So for the OIPMH, we use the implementation of ICAT, and we are disseminating metadata in DataSite, PaNOSC, and Dublin Core format. Okay, we registered on retail data, OpenAir, and B2Find. These are all our repositories. And for the search API, we are using the ICAT implementation with a little change. in an integrated way with a scoring API developed by ESS. Okay, at the moment, currently we are disseminating all the interfaces, disseminate metadata from more or less 7 investigations that are all the investigations that we have open now. That's it. Thank you.
Thank you very much. And now maybe we can go with Luis Maia, XFEL, if I don't remember wrongly. Very good. So yeah, you have 10 minutes.
Right. So first of all, thank you and good morning. So I'm here in the representation of European XFEL, and just before I jump in on what PaNOSC changed for European XFEL, I just want to highlight that when PaNOSC project started, European XFEL was in operation for around about 2 years, which means that we had a fairly recent data policy back then. We have no open data, and we were still setting up and writing, starting with our data analysis and with our pipelines. So having that said, we were having a lot of expectations for the PaNOSC project to help us addressing some of these points. So, and luckily for us, I think we achieved on advancing a lot on the scientific data policy, on how we open metadata, the adoption of Nexus. We even were able to write libraries and frameworks for the data analysis and simulations, and we were able to prepare the concept on how we could make our data open data. Coming a bit on more details. So despite our data policy was from 2017, was already stretching the limits due to the amount of data that is produced in European XFEL. So in the work package 2, there was a lot of work where XFEL was a very interested partner, where basically some of the most important achievements was the definition and explicitly mention of the reduced data, because clearly due to the amount of data that we produce, we cannot strive on having our raw data stored up to 10 years as we aimed for before. Another big important point was the data management plan. And despite we could not deploy it or implement it now during the PaNOSC, we have the commitment to do it in the following months, because our data policy will be reviewed based on the PaNOSC outcome and should be presented to our council next year. So ideally, by the end of next year, we'll have an updated data policy approved by our council and with this information. Concerning our metadata, we are using, as most of you know, a dedicated metadata catalog called Maia. But following all the agreements that we did on Work Package 3, we expose our metadata. So basically nowadays, a few hours after the experiment finish on the beamline, the most important public information is made publicly available via the generation of the DOI in data site. Then all our proposals that are not under embargo are available to everybody having an account. And on the context, we also select the final list of proposals that we even made worldwide public using the OAI PMH implementation from Work Package 3 and the DOI. So besides that, we have our metadata catalog exposed to all the models using the RESTful API, and we implement the loopback definition from Work Package 3 that is then used on the data portal. Concerning the Nexus, we have, so Yuri, Shander, and Aaron were working on an example for the SFX use case. So they took the data from our SPB instrument, they create a virtual data set from it, and then taking into account the geometry and other metadata, they were able to build a Nexus file for the crystallography example. There was also, PaNOSC was also very important because we had the resources to work on the development of Python packages like extra data and extra geom that are basically used by in our facility. They were published on the PanData that it's also available on the EOSC. And basically in this particular case, extra data is very important because allow our users to decouple them from the real file system and how the files are organized and have a simpler way to interact with the data. Yesterday, Mads had a long, detailed presentation about the simulation, but not going to details. LibPy, Vinyl, and CMEX are important, and the biggest message is that they are really used by our instrument experts and by our data analysis colleagues daily to fix problems at European XFEL and to analyze the data. And here we have an example that basically you can take and demonstrate the effects of noise, panel gaps, and masks looking and using these tools. Finally, concerning the open data. So we luckily, together with the colleagues from DESI, we were able to deploy our visa portal where the community at large using the AGI check-in, they could go there, authenticate, and also by a huge effort from ELI. So here we were able to prototype that logging in, anybody could log in Visa, then they will be able to select our open publicly data accessible that arrive here to the Visa from the ETL process from our metadata catalog, and with that you could then instantiate an instance using the Visa singularity image, and then you have access to all this data. That then, or using scripts, bash, CMEX, extra data, or nice Jupyter notebook, you can interact with the data. And this is basically what fixes a bit our concept of how we will provide open data in European XFEL, and this was a very important concept for us. That is, if you don't have the storage resources, the computing resources, that's how you will go. You can go there, log in, and analyze the data. If, on the other side, you have the computing resources and the storage resources, our plan is to allow you to download it using Globus. Same standard, you would log in with EGI, check in. If you have an IDP provider identified there, you would log in, you download, and you can then do it. Finally, there was also a huge effort, especially on work package 5 and 4, on writing papers and also preparing trainings that were placed on the training portal. Finally, just a thank you to so there was a lot of people involved on our site, especially, and would also not be possible without the help of our colleagues at DESI. Right, that's it. Thank you.
Thank you very much. And now we can go with the next speaker for ESS. I believe that is Thomas.
Hello everybody. So for those of you who don't know me, I'm Thomas Rock from European Spallation Source. And I'm here to present what PaNOSC has changed for us at ESS. And I would actually like to, a bit surprised nobody has mentioned collaboration so far, because I think this is actually a big outcome of this project, is that we now have a better understanding of each other that have been involved in the project. And particularly, I would like to mention that we now have shared solutions across the facilities, which should benefit the users. That's at least a complaint among many users that they're facing different solution at each facility. So I think this is really something that will benefit the users. So we're talking about AI, visa, federated search. That's also the PAN training. And according to my search engine, this is a happy user. So there we go. We have also updated our data policy. ESS was born. I should say ESS, for those of you who don't know, is a Neutron source, and we are actually still under construction. We do have some data, but not from ourselves, basically. We were born with open data in mind. So our data policy, the one we have in place now, is actually supporting open data, but not fair data. So there are actually quite some changes to our data policy. And the new one has been endorsed by our executive board, and actually also by our scientific advisory committee. But they gave some feedback that indicated that not everything was clear in the data policy. So we will try to clear that out. There was something about reduced data, because that's an iterative cycle, and you generate many different data sets, and should they all be open, for instance. But the plan is still to get it approved by our council the next time we can get it on the agenda. Our council have many things to take care of for the time being. So that will probably be next year. We have improved findability, ontology for techniques, better search in SciCat. We also got SciCat more exposed. Yes, I can. Is this better? And federated search, and we also have data management plans in place. And also what was discussed at length actually in the previous session is how should we actually service users that take advantage of the open data but did not generate them in the first place. So that's quite an important question. Simulations and training, we've been quite active in both those areas in PaNOSC. First of all, we got Mads on board, and you should notice that his tie is PaNOSC colored, so very dedicated here. But this is a picture from Argentina at the ICNS conference, where he got a prize, innovation prize, from the European Neutron Scattering Association. One of the things he got a prize for is to develop a better and more flexible interface based on Python for MaxSTAS, which is the neutron scattering tool for instrument simulations. So that's really great, and it also means we are moving more towards having digital twins for our future instruments, which is very useful. Since we don't have the instruments in place, we can then use the simulations for testing our data pipelines. We have also managed to sustain what originally were called e-neutrons, developed in previous EU projects. And there was a bit of panic in the community because, how should we continue to sustain e-neutrons? And the solution turned out to be PaNOSC. So now it has been expanded to also include the photon community. It has, as an outcome from the Expand project, been integrated into pantraining.eu. And we have also integrated Jupyter into it, so you can run Jupyter notebooks as part of the course. And this actually means you can use simulations or data analysis, etc., hands-on as part of the course. We had a summer school also as part of PaNOSC a while back, and the feedback from the students were actually very positive about this. And that has encouraged us to set up our own summer school focusing on data and software at ESS. And this is my last slide, so thank you, and particularly to Andy and Jordi and Nicoletta. So yeah, thank you. and to all the staff at ESS that have been involved.
Thank you very much, Thomas. Okay, now we have maybe Teodor at ELI. So he will be presenting what they did and how PaNOSC funding helped at ELI.
Hi everyone. For the people who don't know me, Teodor Ivanoaica, Senior Coordinator for Scientific Computing and Data Management at ELI-ERIC. I'm going through the tools and services which were somehow influenced by the PaNOSC collaboration. At the same time, I'm going to present the policy level support, which has, let's say, impacted the way we defined our scientific data policy and the way we basically construct our data management systems. So, ELI-ERIC data policy and data management plans. I'm going to present how we developed the data policy and how we contributed to the PaNOSC, let's say, deliverables. The development of scientific data management practices, that the two facilities at this point, the third will also adopt the same principles. We have the confirmation from them. Development of first services, because this is a long-term commitment and this is going to be a continuous work, and this will be continued after PaNOSC and maintained by the facility teams and by ELI-ERIC teams. How we promote open science by building meaningful scientific use cases. This is a lesson learned basically from PaNOSC. We had teams in ELI Alps mainly contributing to different use cases. And this is a best practice for us from now on. Basically, we develop best practices, we develop use cases, we show the users how we can support them and how we can improve. And for data services at ELI-ERIC, and basically we will show how PaNOSC has managed to influence our first call for proposals, our first ELI-ERIC call, and basically how the first services are made available. Now, what ELI is, or what ELI-ERIC is basically ELI-ERIC is composed of two facilities, ELI Atos second, so ELI Alps in Szeged, the facility which hosted also the PaNOSC summer school, and ELI Beamlines, which is in Prague in Czech Republic. In the area of, let's say, applications, we support experiments and scientific research in material science and biology, ultra-high intensity interactions, laser development, radiation physics and electron acceleration, plasma physics, and particle acceleration. What I want to say is these are the main areas. There are plenty more, let's say, research areas which take place in the facilities. The information is usually displayed on our user portal, so it can be made available easily. How it is in terms of lasers, or what is the high-power lasers community? And here it's a nice, let's say, graphic showing how the European research facilities are leading this area. And you have in Europe more than 85 and 84 petawatts in terms of power, like a sum of all the high-power laser systems. And ELI itself supports more than 5 petawatts, plus over 1 petawatt lasers, 10 petawatts lasers, which are accessible to users, and 2 petawatts lasers at 10 Hertz. All these are part of the user experiments and user calls and are slowly opened to the public, to the users. Now, how it is in terms of, let's say, implementation, or how we started the collaboration. We went through PaNOSC. So PaNOSC was the driver. PaNOSC has this research data policy framework, which is the driver of our fair data policy. We developed the data policy, and then we contributed to the PaNOSC guidelines and best practices on how to implement, because we had the advantage of not having a previous existing data policy. We used this implementation, let's say, roadmap to also help other facilities and to share, to return to the community what we received at the beginning of our work. At the same time, the data policy is already in production and is driving the first ELI-ERIC user call. And you have here some of the statements, which are mission statements for us, which are extracted from the data policy. We have an embargo period of 3 years. We aim at storing the data for 10 years. The metadata shall be stored forever. There is going to be a central data repository at the level of ELI-ERIC. A replica of the data will be hosted by each of the facilities, so a user will have a backup of that data set, which is stored by ELI-ERIC at each of the facilities and so on. However, there is going to be a central data portal, a central set of services, which is the develop fair by design tools and services for our users. This is another commitment. We need to establish ELI-wide data and metadata standards and support their implementation and their adoption at the level of the facilities, because the sites were in commissioning phase. They were commissioning experiments, commissioning beams. So there was not a direct focus on this. There are already existing practices, so there is not a huge amount of effort in this, but needed in this, but it needs to follow the same structure, the same roadmap. Sharing the data will take place after an embargo period. The embargo period can be extended with up to 2 years, so the user can request the extension of the embargo period, and if it's approved by by the scientific board, that embargo period can be extended. At the same time, a user can say my data should be openly available in 6 months, so it can also be published even before the embargo period expires. At the same time, we have a multi-stage DMP because we use this opportunity to train the users. The data management plan is not one of the existing practices in the high-power laser scientific community. So basically, we don't want to kill our users during the proposal submission. We just want to train them and to make them understand what's the importance of the data management plan and how this helps, let's say, or how this accelerates their science. The DMP strategy, as I said, for the first ELI-ERIC call, so it's a multi-stage. The stage 1 during the experiment, the proposal submission, we collect the minimum required information about the experiment. And the second stage is in the experiment preparation phase, so it should take place when the experiment is scheduled. And there, the facility team is going to get involved in supporting the user to provide the necessary information. At the same time, for this second stage, and in order to accelerate, and it was a good discussion and a good presentation yesterday about the DMP and the importance of the DMP, but it can be fine-tuned by the instrument scientists because they know how and they know what data they deliver, and they can make the list of questions shorter. So basically, instead of going with 50 questions discussing with a beam scientist or instrument scientist, you can make like a list of 20 relevant questions which makes sense for the scientist, and the rest will be documented at the later stage. So we are supporting and we are trying to find a way to accelerate the adoption of the data management plan. Data stewardship is also deployed. So data stewardship wizard is also deployed. It's not used at this point. It's going to be used, so we plan to use it. We plan to follow the same standards. We can easily consider a central data stewardship wizard platform and have this managed for the entire community. So we are open to this, but it's not yet in production, not for the first call. Oh, okay. Then, data custodianship and data stewardship. So we have ELI-ERIC as custodian and is directly responsible to collect, secure, archive, and provide access to data for the users. And this is a basic data stewardship workflow discussed and agreed with our colleagues at ELI Alps, and it's pretty much ready for the first call. So we have this agreed, and this is how we plan to manage. And then the custodianship part, which will require a lot of effort on our side in order to implement the IT infrastructure to support this, because this is something that we need to coordinate at the level of ELI-ERIC. Development of fair services for the first ELI-ERIC call. We have pretty much all the services that are part of the PaNOSC data commons. We have selected for this first call and for the future calls for a period and testing and evaluating in-venue RDM at this stage. It's implemented by our colleagues at ELI Alps, following the best practices in PaNOSC. We have identity management system, so we have tested Keycloak, but for the first call, we are going to use a local identity just to make sure we control, and we are using systems that are in production at the facilities. The data portal for download is going to be also made available. For the first call, this data portal will be a custom development in the future, so it's going to grow and take over. We are planning to support ORCID and Umbrella ID. Both of them were tested, so we are going to go that way. Open science services, we are supporting PaNOSC search, and we have the API support for this. We are providing OAI PMH endpoints, so everything is following the PaNOSC, let's say, best practices. I'm going to accelerate. My colleagues in ELI Alps are now following up on the Nexus application definition in NX scan and PANET angle You see here the Nexus HDF5 approach, and there is one of the experimental end stations. As we said, we are using use cases. So we have our champions in the facility supporting the software engineering group in implementing and developing Nexus and HDF5 for ELI. At ELI Beamlines, there is work on the, let's say, web portal, web services, and they are going to follow up and basically try to deploy Visa and support Visa, at least for a while, to evaluate it, and then ELI-ERIC will migrate Visa at the ELI-ERIC level on our infrastructure. Use cases were promoted and used to train users and scientists in adopting fair data and fair principles. And for the first call, this is how, let's say, the data management will look like, and this is the clear connection from the metadata catalog to EOSC supporting PaNOSC first search, federated search, and the entire data management system inside ELI-ERIC. So I accelerated as much as I could. Thank you.
Thank you very much, Teodor. And are we done? Are we missing someone, Andy?
Yes. Okay. Yes, I have to speak here. So actually, I thought it's just important to notice that when we were starting PaNOSC, we were fully into an upgrade of what's called a fourth generation storage ring. So fourth generation storage ring is one huge project of 150 million euros. And what basically you do is you start with this very elongated, horizontally elongated beam, and after a lot of work and a lot of people, a lot of money, you get this round beam with more photons concentrated in the center. And this was started, and as I like to quote Panteleo used to say, the body of the car remains the same, but we took out the old motor and put in a new engine of a Ferrari. You can see which country he comes from. Yeah? And this was, we shut down the storage ring on the 10th of December, and we started PaNOSC on the 1st of December. You can see there was like, it was, well, you could see it as bad timing. Fortunately, who have had to have a lot of time spent on PaNOSC, where all of the work involving the control system, the beamlines and that, there was a huge team of very competent people there. So I could spend time on PaNOSC over the last 4 years. And we, at the same time, upgraded the entire storage ring source, which is a very big, let's say, step forward towards what the kind of experiments people are doing now. And yes, so I could say what it also gave as an incentive, and also the resources, was to adopt these changes directly on the first beamlines, because we were doing new science. The idea is to do new science on these with a new source. So a number of beamlines were constructed and others were upgraded. And we said any upgrade to a beamline or any new beamline must implement everything that we wanted to do in PaNOSC already. So like the fair data principles and the changes to the data format, all these things were done as part of this EBS project, but financed by PaNOSC. So if you want the high level answer of what PaNOSC changed for the ESRF was, we definitely made data fairer. It's still an ongoing process. And we also helped build what's called the PAN, I call the PAN EOSC, the PAN version of the EOSC. So the data that's all out there, the human organ example that you have, but also all the other open data is actually part of this photon and neutron EOSC, I would say. So this is really what I would, from the high level point of view, and what I would tell the European Commission. But when I go back to the ESRF this afternoon and I speak to my scientists, this is all gibberish to them. They would say, well, okay, it's nice for you to say you've done this, but it doesn't actually help them. They don't see where this helped them. And this was a comment also made by Majid. How does this help the scientists? How do you convince them? And seeing as I'm coming from a software background, I spend most of my time making sure that the things we were working on had practical advantages for the scientists. So I have this long list of things here, which were all mostly either software or infrastructure related things that had a direct impact on the users or on the beamlines. And these are the kind of things I think if you want to convince them why to do FAIR or why to do, why we were involved in PaNOSC, you have to speak at this level for the person who is spending probably 20 hours sometimes in the hutch taking data. I won't go through them all because I wanted to go through them in a different way, but what I actually wanted to show, and also, of course, we are now pushing the agenda of open science. So we started together with CERN and EMBL and the other IRO forums, preparing an open science policy for our facility, which would then have also a lasting effect that not our users, but ESRF staff would be more bound to or more aware of what they have to do to implement open science. And also, just to give you an idea, this is a huge job of, I just took a snapshot this morning of the last 12 months of data collected and curated in our catalog on 44 beamlines. So of the 44, 42 are really operational. There's one you can see, I think it's probably, if we look here, ID20. You see ID20 has only done a small test here. So that still has to be completed, and the ID28 is also missing from here. But this is the work of many people, but also Alex behind there, he's also spends a lot of time making sure that all these services behind here, the ICAT, but everything involved with that is also working. So what I actually thought we should just remind you of who the people were who were involved with this. So also thanks to Rudolf. We also got Alex and Marjolaine, who spent a lot of time making sure that the implementation and the electronic logbooks and the data portal are there. So there's still a lot of work. Nexus, I think we can thank Wout, who is our member of the Nexus Advisory Committee, as well as Matthias, who is the main developer of Bliss, because with our new control system, we generate automatically Nexus everywhere. The DMPs, Marjolaine did a huge job there, and I think you've seen also other people now. Data visualization, we have Loic, Axel, and Thomas who've been involved with that, and I think the H5 Web has had a fairly large impact, we can say. Thomas and Loic worked on Jupyter Slurm during PaNOSC. So these were all people who put in timesheets for PaNOSC, and I'm happy to say that with one exception, these are all permanent staff members, so they're going to continue also the work that we did. Oasis was Manolo, Juan, and then even my daughter. And we had for Visa, we had a whole team, which is actually the people working in Jean-Francois's team. So Antoine, Aiden, Cedric, Francois, these people, and we even have Jordi, who is now involved in Visa, getting Visa working on the beamlines. Search API was Alex. He did a huge job debugging what the SDFC team did inside ICAT, and I think we can now safely say it's working. So there's always improvements that we can do. I think Axel helped working on the front end for the Human Organ Atlas. Alex was involved with defining and ingesting the data. Jean-Francois and his team for making sure that the infrastructure was there. Then the data transfer problem, the fact that people couldn't move data sets larger than 2 gigabytes without a lot of effort setting up an rsync or becoming a computer specialist, they could now do it with Globus, for instance, something which was, you can see from the slide that Jean-Francois showed, this is a big change, yeah, for people who want to move large data. And then the e-learning platform, we had Marius, I don't know if he's still here, Marius, and also Manolo, and actually even I wrote a small, provided some training material and had experience with that. And also thanks to our management who have put open science on the agenda now. So I think, you know, these are all practical things that actually have had practical changes in the way people are using our facility or people working on the beamlines. And of course, there's a lot more you can say. So even now PaNOSC is now ending today. There's a lot of things that we're thinking of doing after this. Yeah? So these are the continuation of these things. And then finally, yes. I think some of you have heard during, when I have Zooms, you've heard my cat. Well, yeah, you can see. And I think that's all, yes.
Thank you very much, Andy.